Hello everyone, welcome back to my channel. Today we have this PS4 which does not power on at all, so I already started testing it and found out that this power supply is actually the cause that this PS4 does not start. So I tested the standby voltages and I found out that there is no voltage at all at the standby connector, this connector over here. So when we turn it on, we should see 5 volt there at this connector. So from this pin to the one next to it, we have 0. And the third pin is also 0 and the fourth pin is 0. Now if I go to the second pin and third pin, we have 0, and to the fourth pin is 0. Third to fourth is also 0. And if we check, the 12 volt rail is also 0. So this power supply is not working because of the missing standby voltage. Okay, let's take it apart and see if we can fix this power supply. Okay, so the power supply is opened. So let's check first these big capacitors if they still have voltage. Okay, so at this one we have 347. Look how much voltage they stored until now. These capacitors are really dangerous. You need to take care when disassembling these power supplies. So I want to discharge them. Okay, now we have how much? Just 5 volts. Six volts. We can discharge that using a tweezer. And now we have only 0.9 of a volt. So now it's safe to handle and touch. Let me clean it a little bit. It's really dusty. Okay, so here is the power supply board. As you can see here, we have the input section, the input connector. It goes through a fuse and filters, capacitors and inductors, and then goes to this bridge rectifier. Then it goes to this BFC transformer, and then from the BFC transformer it goes to the capacitors, the big capacitors here. And we know that we have voltage here. That means the BFC circuit and the primary side is actually good. But the secondary side, which is at this transformer here, is not good. This is the main switching transformer. This is the main transformer that provides the 12 volt at this connector. And this is the standby voltage transformer, which provides voltage at this connector. If we zoom in at this connector, as you can see, we have AC in detect, AC DC standby, ground, and 5 volt standby. So this connector should have at least 5 volts at one pin of it. Why it doesn't? There might be some problem with it. Let's check first for a short at the connector. And here is the connector. It says here ground and 5 volt standby. It's not shorted. 5 volt and ground and the other 2 pins, and is not shorted. Let's check this MOSFET. So this is not a MOSFET, it's actually used as a diode because of these pins are connected together. So this acts as a diode. Here is the capacitors. They stand by 5 volt. Let's check this capacitor for a short. It's not shorted. So why it is not working? Let's check this diode here. The diode is good actually. Okay. So we need the schematics. Let me find the schematics. Okay, so here is the schematics of this power supply. This power supply model is ADP-160CR. I hope you can see this schematics. So this contains two bays. The first one is the PFC and SMBS circuit. So this is the PFC circuit and the switching mode power supply circuits, which provide the 12 volt here. So as you can see from here, we have the rectifier, AC in, then the rectifier, then BFC IC here, which controls this transformer. Okay, then these are the charging capacitor, the big capacitors, and then goes to the SMBS circuit, which is this one, the transformer and these two MOSFETs and this inductor over here. And these MOSFETs are controlled by this IC, which is IC32. Okay, the other one is the standby and protection circuit. So this is where we need to look at. As you can see here, we have the connector says 5 volt standby. It goes to 2 capacitors, then to inductor, and then to a resistor. And from this resistor, it goes to those 2 diodes, which I think it is this one. I think it's this, which looks like a MOSFET. It's written there D101, which is actually there. Let me zoom in so you can see. So it's written over here is D101, and also it's written here D010, or I mean 101. So yeah, this one is actually this diode over here. The input of this diode is actually straight away from the transformer, from this transformer. And what controls this transformer is actually this MOSFET. The switching MOSFET is actually this one, which is Q9. Let me find Q9 where it is. So Q9 is actually this one. And I tested this and it is not shorted, I think. Let's test it again. It is not shorted. Yeah, it is not shorted. It's reading good and have no shorts. The gate of this MOSFET is controlled by this IC, IC31, which is, I think, would be this one. Yeah, it is this one. And this IC looks a little bit discolored. I think it is. Let's go under the microscope so we can see it. Okay, so the IC is this one. It says DAP041. And on the schematics here it says DAB041, exactly the same, IC31, which is this one. As you can see, it's a little bit discolored. I don't know if it is faulty. There is a spot, black spot here, as you can see. So it could be the cause why this standby is missing. So we need to replace this IC. Unfortunately, this IC, if we search about this IC, I think we will not find anything about it. But I do have donor boards, so I will replace it from the donor boards. Let's first check the pins of it, if there is a short. Let me first try and find the datasheet of this IC. Okay, so its part number is actually SCY99194. As you can see, it's written here DAB041. So this is a fixed frequency current mode controller for flyback converters. I want to know the pins. So pin number 4 is ground. VCC is pin 6. Pin 8 is the high voltage, so we should see high voltage here around 300 something. Feedback, chip select, latch, and drive. This is to drive the MOSFET, which is Q9. We said it is. So let's check ground to VCC, ground to DRV, and see if it is shorted. So the ground is pin number 4. Here we have number 1. So this is 1, 2, 3, 4, 5, 6, 7 pins. Here is no pins. Okay, so from pin 4, this one, to 6, it is not shorted. And to DRV, it is not shorted. And to high voltage, is also not shorted. Yeah, it is not shorted. This resistor what provides the high voltage. These two, or I mean this series of resistors provides the high voltage pin with the voltage. And this pin, the VCC pin, goes to this capacitor and to here. Okay, so I don't see anything wrong other than this IC is not doing its job. Let's check the component next to it. So we have here a diode. It is good. So everything seems to be normal. Yeah. I don't see any reason why it is not switching. There is no shorts, no nothing, no blown components. Everything seems to be good. This is NTC. Yeah, so I think I will replace this IC and see if it will work. First, let's check the voltages before we replace it. Let's check how much voltage do we have at pin 6, which is the VCC pin. According to the schematics, let me go to the main camera again. According to the schematics, VCC pin is to be connected through this diode D22, which is this one. This little one, this diode, is what connects to the VCC, which is pin 6. And yes, it is. And from here, we should see it's going to a 0 ohm resistors. It's a J13 0 ohm. So this is just a jumper. Yeah, so this is J13, it's a 0 ohm resistor, and yeah, it is coming here. And after this resistor, it goes to the VCC bin, which comes through this line here, which is 20 volts. It's written here 20 volts. So we should see 20 volts at the VCC bin. Let me check the datasheet. What does it say about the VCC bin? So yeah, the VCC bin is actually bin 6 says this supply bin accepts up to 28 volt DC. With overvoltage detection, the bin is connected to an external auxiliary voltage. So it could be 28 volts actually, as what is written here. It says 20 volts. You didn't see that. Okay, so it comes through, this is the VCC bin at bin 6. Comes through this D22, which is this little diode over here. And then goes through this J13 0 ohms resistor, which is this one, and then comes through this line, which is auxiliary line from the main transformer, from the standby voltage transformer. So we have D21. Let me find D21 and measure it. So D21 is actually this one. I think we measured this one. Yeah, it is good. From D21, it goes to this capacitor, C2500 microfarad, 35 volts, which I think it is this one. Yeah, it is this one. So let's check this capacitor. Yeah, this capacitor is not shorted. So I want to check the voltage at this capacitor and at bin 6 of this IC. Okay, so you can see I will use my box to limit the current. If there is anything goes wrong, the lamp will illuminate. Okay, the lamp flashed. That means we have voltage at those big capacitors now. If we check this big capacitor here, we should see 300 volts. As you can see, 337 volts. So the primary side is working. Let's check the voltage at this capacitor. We don't have any voltage here. That's why it's not switching. What about before this diode? No voltage at all. So why it's not switching? Let's turn off and check the schematic. Okay, the schematic says we need to check the high voltage bin. The high voltage bin is connected to a series of resistors that provides the startup voltage. So we need to check bin 8. If bin 8 is not providing the correct voltage, then this IC will not start. The datasheet says the high voltage bin connects to the rectified AC line to perform the functions of startup. As I said, so it's the startup bin. Okay, so let's check the bin number 8 of this IC. Let's turn on again. So it's on. Let's check this capacitor again. So we have 337, as you can see. I want to check from bin 4 to bin 8. So we have 201 volts. So it is provided with the voltage through this series of resistors. So why it is not switching? It's not starting up. So I think it is that IC is faulty. Let's turn off and let's discharge the capacitors. So we need this IC. Okay, so here is a donor board. So let's take the IC. Okay, so this IC is out. Okay, now we need to take the IC of this board. Okay, the IC is out. Let me clean the board, and then we can install the new IC. Okay, so let's test now. I think the board is cold enough and the IC is installed, the new IC. Let's clean it a little bit. Okay, let's go to voltage mode and let's connect the power cord and see if it will start working. Okay, the power is on. Let's check again this big capacitor here. So we have 337 volts. Let's check the voltage at this capacitor. It's still 0. And how much do we have at this connector? 0 volts. So standby voltage is still missing. VCC line has how much? $11 volts. Where does it come from? The high voltage has 214 volts. The VCC bin has 11 volts. Yeah. Okay, so it's actually 11 volts is enough to drive this or to make this IC starts. So it's not, the VCC is not missing or it's not low. So it's good. Why it's not switching? So we confirmed that we have the high voltage, which is 214, I think it was. And we confirmed that we have the VCC, which was 11 volts. So then I think it should start driving this Q9, which is this MOSFET here. This MOSFET, this one, this is Q9. So it should start driving Q9 straight away. Why it's not driving Q9? Okay, let's check. Let's check the voltage is actually there or not at this transformer, which is 360 volts, which comes from here. Let me show you. So it comes from here. This is the main transformer, which produces the 12 volt rail. And as you can see, we have here 360 volts line, which comes after the PFC circuit through this 0.1 ohm resistor. So this 360 volts is provided for the first transformer to provide the 12 volts and is also going here 360 volts which goes to the standby voltage transformer. Let's check if we do have this 360 volt there. So let's turn on again. Let me zoom out so you can see the multimeter. Okay, let's turn on. So it's on. Let's check the capacitors again. We have 338, as you can see. So it's this transformer and it's Q9. So we should see voltage at both ends of this transformer, of this winding of the transformer, if it is not switching. If it is switching, we should see 360 volt at least at this pin. So let's check if we do have that. We need a ground. So it's the hot ground, so we can use the one from the big capacitors. So at the Q9, we have 0. And at the other pin is also 0. We should see 360 volt here. Why it is not there? So where is it coming from? We said it comes from here, which is at Q3, the drain of the Q3. Let's check Q3. Where is Q3? Q4. Yeah, this is Q3. So if we check here, we should see 360. We don't have 360. Why we don't have? Okay, let's go back. We have this 0.1 ohm resistor and then the big capacitors. And we confirm that it is there at the big capacitors. If we check here, yeah, 338. So we need to check this 0 ohm resistor. Where is it? Let me turn off. I think it is this one over there, if you can see it. That one, the big one here, this one. Let's check the voltage before it and after it. Okay, let's turn on again. So it's this one. Before this resistor we have 338 and after it 0. So yeah, this resistor is actually faulty. So it is from the beginning that resistor, it's not this IC. Let's turn off. So we need that resistor. Let's discharge the capacitors. Okay, so this should be a 0 ohm, 0.1 ohm resistor. Let's check it. We have 10 mega ohms, so it is blown. It doesn't look blown. It seems fine actually. Let's take it out. Okay, so here is the resistor. It actually looks completely fine. No cracks, no burns, no nothing. So why it's not doing its job? Let's check it again out of the circuit. Yeah, it's open actually. It's completely open. It's open circuit. So we need this resistor. Do we have it here? Yeah, we do have it here. Let's check it. This one is good, 0.4. Okay, let's take it. Okay, so here is the resistor. .4 ohms, and this one is open. Let's install it. Okay, let's try it now and see if it will work this time. Let's do it like that. The power is on, and there is something exploded over there. It's actually, that's why that resistor was blown. Something exploded over here. I don't know if it is this MOSFET. I think, yeah, it is this MOSFET. So this MOSFET is actually, we tested this MOSFET, it was good. Okay, so let's check that resistor again. Is it still good? I hope so. Yeah, it is good. So we need to replace this MOSFET. Okay, so the MOSFET is out. I want to check it out of the circuit. It reads 0.2. It doesn't read it's completely shorted, but I think it's not good, and I can see it exploded. So let's replace it. This one reads good, 0.5. Let's replace it. Let's take it out. Let's try it again and hope it does not explode this time. Okay, the power is on. It did not explode this time, and we should see 5 volt at the standby connector here, and we have 4.8 actually, so it is working. And we have 19 volt at this capacitor now, so now it is working. The capacitor I just measured is this one, C49. Now it does have 19 volts. That's why it's written here it should has 20 volts. So yeah, this schematic is actually correct. So this power supply is now working. Let's put it back and try and turn on the PS4. Okay, so this resistor is faulty and the MOSFET is faulty. The MOSFET was faulty actually, that's why this resistor is open. And this IC I think is good. I will return it back to the donor board. So let's put it back and test it. Okay, let's turn on and let's hope it turns on with no issues. Okay, it's on. Let's press the power button. And yeah, it does work. I have limited the current. So now it's at 200 watts. Okay, so it is working. I want to see a picture. We have the white light here, but we don't have picture. Let's go to position 3, and yeah, we have actually picture. We have picture. Let me connect controller, and it is working. Okay, so I hope you enjoyed this repair. If you do, please don't forget to like, share, and subscribe. Thank you so much.